welcome to our next lesson, 5.4 in our 8th grade Big Ideas book, page 226, where we are going to solve a special system of linear equations. Our essential question will tell you exactly what we're going to have. How can a system of linear equations have no solution? If you remember from Unit 3, when we solved equations with variable on both sides, if we had an invalid statement, we had no solution. That might have something to do with our system. And how can a system of linear equations have many solutions? Many solutions, if you remember, was a valid statement. And so I'm sure that that has something to do with what we're going to be doing today. So, taking a look at what you should have taken notes on, solutions of systems of linear equations, there are three. There's one solution, no solution, or infinitely many. And so far, we have talked about solving by graphing, solving using substitution, and solving using elimination. And every single time we've done that, we've ended up with one solution. Why? Because we have equations where whether we graph them or whatever we do, we have an ordered pair because lines would intersect on a graph. So we have one solution. In other words, the equations were different. In other words, we have different slope and we have different y-intercepts. Okay? So the equations are different, which gives us different slope and different y-intercepts. If we had a graph that had no solution, we would have parallel lines. And what do we know about lines that are parallel? That's right. The slope is the same. So we would have equations with the same slope. However, the y-intercepts would be different. So these two parallel lines have the same slope, but the y-intercepts are different. Lastly, we have a graph where they end up being the same line. The same line. So there's two graphs on there. There's two lines on this graph, but they're the same line. So we would have infinitely many solutions. In other words, the equations are the same. We have the same slope. We have the same y-intercepts. We have the same equation. So, one solution, the equations are different. In other words, they have different slopes and different intercepts, completely different. We have solutions that are no solution because the lines are parallel. Parallel because they have same slope, but different intercepts. And then we have infinitely many solutions where the lines are the same because they have the same slope and the same intercepts. So in this video, we're going to actually concentrate on systems that have no solution. In our first example, 3x plus 5y equals 1, negative 6x minus 10y equals 14. I'm going to solve both of those equations for y and write this equation in slope-intercept form. So I'm going to take this first one, and I'm going to subtract 3x from both sides. That would give me 5y equals a negative 3x plus 1. Dividing by 5, every term, y would equal a negative 3/5 x plus 1/5. Now I'm going to solve the second equation. I'm going to actually add 6x to both sides. And I have negative 10y equals 6x plus 14. Dividing by a negative 10 both sides, every term, y would equal, well, 6 over 10 is 3/5. And 14 over 10, oops, that's actually subtraction. We're actually subtracting 7/5 because that's a negative 10 at the bottom. So what do we have here? That's right. We have two equations, but these two equations have the same slope. And they have different intercepts. So if we have the same slope and different intercepts, what's the solution to this system? That is absolutely correct. No solution. No solution. Moving on. We have y equals negative 5x minus 2 and 5x plus y equals 0. Wow, I learned that I could use substitution, and I'm actually going to substitute that in there because I have a variable that's already solved for. So I'm going to rewrite this equation, 5x minus 5x minus 2 equals 0. Combining these two terms, that's 0x. It goes away. That leaves me with negative 2 equals 0. That is an invalid statement. Invalid statement means no solution. We learned that. No solution with an invalid statement. The other way we could tell is if I did solve this second equation for y, I would get y equals 5x. And then there's no intercept. So they would have the same slope of negative 5x, but they have different intercepts, negative 2 and 0. So we would have no solution. Going to our last example of this video. 2x plus y equals negative 3, and negative 6x minus 3y equals a negative 2. In this particular case, I'm actually going to use elimination to solve this one. I'm going to multiply this first equation by a positive 3. And 3 times 2x, that's 6x. And 3 times y, that is a positive 3y. And 3 times a negative 3, we equal negative 9. Now when I add these together, I have a negative 6x and a positive 6x. That eliminates. I have a negative 3y and a positive 3y. Wow, that eliminates. So on this side, I actually have 0. And a negative 2 plus a negative 9, that's negative 11. Once again, what do I have? An invalid statement. And that means no solution. If I were to graph both of those, I would have parallel lines because I'd have the same equation. I can prove it real quick. If I subtract the 2x from both sides on this one, I would have y equals a negative 2x minus 3. On the second one, adding 6x to both sides, I would have negative 3y equals 6x minus 2. Yep. And then, when I divide by a negative 3, I would have y equals a negative 2x, and I'd have plus 2/3. I'd have the same slope of negative 2x. I would have different intercepts, and so I would have no solution. Ladies and gentlemen, your first quick write of the night. Write down this special system of linear equations. 2x plus 14y equals 4, and x plus 7y equals 7. Solve it, and yes, we already know the answer is going to be no solution, but you have to be able to prove to me why it has no solution. I will see you back here in just a few moments after you take a quick break for video number 2.